welcome once again. So today's we will discuss about the geometrical representations of the linear and the quadratic polynomials. So geometrical representations here, so we know that a real number k, the real number is equal to k, and the zeros of real number k is equal to px is equal to k. Got it? So zeros of k is always be pk is equal to 0, or we can say that pk is equal to 0. Okay, so we can represent these zeros in two ways. Either the geometrical representation, or in two way of linear and quadratic and their geometrical meanings. Geometrical meaning of zeros. Geometrical meanings of zeros, we will study here. So first we will start geometrical meaning of zero. Geometrical meaning of zeros of linear polynomials. So first, geometrical meaning of zeros linear polynomials. Zeros of linear polynomial. Okay, geometrical meaning of zeros of polynomials, linear zeros of linear polynomials we will study here. We know that linear polynomials, linear polynomials. What is linear? Ax plus b. So ax plus b is equal to y. This is the linear polynomials ax plus b, where a is not equal to 0 and a is not equal to 0. We know that it's a linear polynomials, which we know that y is equal to ax plus b. So a straight line, find a straight line along x-axis. Okay, a straight line along x-axis, and which intersect at x-axis exactly 1 point. Which intersect at x-axis at 1 point. Okay, so exact intersect x-axis and 1 point, and also we know that here is the namely here is the ax plus b is equal to y. So ax plus b is equal to 0. So if we know that x is equal to minus b by a, got it, or 0. So 2 point we have got here, x and 0, 2 points. So but only 1 point b by a minus b by a, and 0 cannot be considered. So 0 is no points, and ax plus b, thus zeros of ax plus b is x coordinates. Thus zeros of ax plus b is x coordinates. Okay, so ax is a coordinates, and zeros of, so we know that zeros of x, thus the is points, x coordinates are points, where graph of Okay, we can draw the graphs. We can draw the graphs. So ax plus b is equal to y by these linear equations. So we will draw here the graphs by this axis. For examples, here is the intersecting point at A. At intersecting point at x axis. Okay, so intersecting points will always be a x axis. So we will take the example for this one things. Take the example. Take example. Okay, suppose that here is the represented linear polynomials 2x plus 3 represent the polynomial linear polynomials 3x plus linear polynomials. Here's 2x plus 3 on a paper, graph paper, on a graph paper, and also find the zero of it. What is, so here is the questions. Suppose that we know that, so let's we have solution. We have, here is we have y is equal to 2x plus 3. Got it? So y is equal to 2x plus 3. So we can write here, so the value of y is in the form of value of y in form of 2 in along with the x is at we will find 2 or 3 point, 2 or 3 point along of 2 value, 2 or 3 value of y along different x axis of x, different x, okay, axis of x value. So here is the, suppose that this is this 1 2 3 value. So here is the x and this is y. Here is the x and this is y. Is we have taken x and y. Here is x2 minus 2. Suppose that if x is minus 2 and y is 0 and 2, and taking 0 and 2, then y will always be calculated by x is equal to minus 2. So 2x plus 3 is equal to 0. So 2 into minus 2 plus 3 is equal to 0. So we will calculate here. So find ours minus 4 plus sorry 2x plus 3 is equal to minus 1. So if we substitute this value in this, so we will calculate here. So 2 2 are 4 plus 3 is equal to y. Then y value always be, so it becomes minus 1. So here is minus 1, and if we substitute this value is 0, so it becomes 3. Got it? So minus 1 and 3, and if we substitute 2 value, it becomes just like a 7. After calculators we will find here, and then after we will draw here the value that we have find here. So draw here, suppose that these are the equations, and here is the x dash y dash. Okay, x is we have find here. So how many? 7. Total number is here 7. 1 2 3 4 5 6 7. 0 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 and 7. These are the value. Okay, so first x coordinates of points, we will write here a point. point first x is here minus 2 a. Suppose point a is here minus 2 and minus 1. B points will write here 0 and 3. C point right here some 2 and 7. Then here is the point we have find. First point is here minus 2 and 1. So minus 2 we will see here and 1. If we have find here minus 2 and 1. So minus 2 and 1 is here. So we have got here minus 2 and 1. So this is the minus 2 and 1. Second point 0 and 3. So y-axis is plus 3. So positive here is the plus 3. Okay. And so here is 7 minus 2 and sorry 2 x-axis is 2 and 7. So 2 here is 2 and here is 7. So second will be here is 2 and 7. If we meet these lines, we will get here the straight line path that will find here straight lines. This becomes the straight lines, and the right here so it is 2 point C 2 and 7. This is point B, that is called 0 and 3, and this is point A, that is minus 2 and 1 minus 1. So here we have got here the points each one, and calculate here and draw and find out the we have find that it's a straight line path has been obtained. Now we will discuss about the geometrical meaning of the zeros of the quadratic polynomials. Now second point, we will understand the geometrical meaning of zeros of geometrical meaning of zeros of quadratic polynomials. So geometrical meaning of zeros of quadratic polynomials we have to study, because we linear equations, linear polynomials we have studied here. Quadratic polynomials graphs we know that's correspond y is equal to, we know that's the polynomials here is a quadratic equations, here is a x square plus bx plus c is equal to y. This is the quadratic polynomial. Ax square bx plus c is equal to y. Okay, has one of the two shapes which is known as parabola. Has one of the two shapes, that is parabola. So two shapes here is the parabola, opens up and open down, two shapes. If open ups and parabola and on and either open upward like either open upward like this, if a is greater than 0, and open downward like this, if a is less than 0. If a is less than 0 in two conditions, if the a is less than 0. So if a is greater than, so y is equal to is like this, and if the if the a is equal to always be 0, in these conditions of quadratic equations, ax square plus bx plus c. In this quadratic equations, if a is greater than 0, then it will be a open upwards, and if a is less than 0, it will be a open downwards. So here we got the parabola. Now so for observations about the shape of the graphs, so the following three cases arises. Then on the basis of graphs, on the basis of observation, the quadratic equations equations ax square plus bx plus c have arises three cases to form a graph. To form a graph, so first case, suppose that it's the first case if the graph intersect or touch x-axis exactly 1 point. Okay, if graph intersect or touch x-axis at exactly, okay, touch or intersect exactly graph axis at 2 point, at 2 point, like this. Suppose that these are graphs and it is intersect means that at intersect at 2 points. Suppose that this, like this. Okay, so 2 points is intersecting at 2 points. So one is a dash and a dash. Two conditions here as x dash y dash here. So x dash y dash. So here is the a 2 point A and A dash, and the second graphs will also be like this, and the upward directions. Here is the 2 point A dash, and x dash y dash. Okay, these are the axes, and 2 point we have got here. So x dash and a dash, and so x dash y dash, and at a point O, this we have got it here. And second conditions, if then in these conditions a dash and the case it is coincide here. So ax square bx will quadratic equations are the likes two zeros of the quadratic polynomials. It form two zeros of quadratic polynomial ax square plus bx plus c. Okay, ax square bx plus c, two zeros. In second conditions, if graph intersect at x axis at 1 point, exactly at 1 point. So in this case, if the graphs intersect exactly x axis at 1 point, then the two points a dash in case coincides, then it will be coincide. Suppose that here is a graphs, and this is graphs y dash, x dash, x dash, and y dash. Here is exactly, suppose that these graphs intersect at 2 points like this. Suppose that this is like this. Here is a, okay, and here is, suppose that this. Got it? So exactly 2 points it intersects. So it will always be intersect at 2 point coincide only one intersecting point A, obtain the x coordinates A only the zeros of the quadratic polynomials. So zeros of polynomials we will get here exactly 1 point. So this condition, and the third conditions, if the graphs, in case of the third conditions, if the graphs is either completely above the x-axis, if the graph is either completely above the x-axis or below the x-axis, above the x-axis or below the x-axis, what happens then? Like this. Suppose that this conditions. So above the x-axis or below the x-axis conditions is here arises. So a is always be, here is a is less than 0. In these conditions, so here either exactly below the x-axis, not touching, no touching, or above the x-axis, x dash, y dash, y dash, and x dash. So exactly at no touching points here, so we can see. So always be a is greater than 0, and here is a is less than 0. So it is also second point. So here is a is greater than 0 and a is less than 0. But in this case a will always be a is less than 0 and a is greater than 0. So a is less than greater than 0 and a is less than 0. Three conditions here involved. So geometrically we can say that, so we can observe here, so in different cases and in different cases and have a try to find out so uh, which exactly that gives the proper meaning of the graphical representation. Suppose that's the five questions. So here's some questions means that vertically, so we know that quadratic polynomial can have either two distinct zeros or two equal zeros. Means that's two distinct zeros. Quadratic polynomial to have this have two distinct zero. Okay, either two distinct zeros or 2 points. Okay, equal zeros. So equal zeros, that is the one zeros, that is 1 0 as no zero. So for this only the polynomials and the degrees 2 has almost 2 zeros. So always be the quadratic polynomials, we can say that's always be a degree 2 degree. 2 degree containing the polynomials. Yes, we can consider it's a 2 degrees and containing the polynomials, and the path will always be different. So suppose that's a question is given here, some questions are then generally arises here, and telling you some things associated with the questions. Here is our place is given here, so we will try to find out which of the following are of the graph of quadratic polynomials. Means that's if the graph is given here, suppose that 1 2 3 and 4 graphs is given here. So I have drawn here 4 graphs, and in case of 4 graphs we have drawn here, and with the help of graph and its representations I have given you questions. Here is the questions and questions, and its a graph is telling that which is quadratic. Means that this graph is given here, so like this, and the second graph is below like this, and the third graph is here like this, and the fourth graph is like this. Means that this like this. So here is the 3 point. It's the 3 points. Means that A, B, C, and D. 4 point is given here. So according to this 4 point is given in these 4 points. So first, fourth, D options that intersect the graphs at 3 point. 3 point. But other have it's have a 2 point. It's have a below, downward, open, no point, this 0, and it's have upward, no, open upward, no points. Means that no touching points. Means that it's a this first second A B C can consider, but D cannot consider because it's intersect the x-axis at 3 points. So that is why we can say that this is not a quadratic polynomial, but other is a quadratic polynomial. It's easy, you can recognize it. So here we have discussed a lot and have given you a different process by means of which you can solve the quadratic and the linear polynomials. Recognize how to recognize the quadratic and the linear and the geometrical, how to represent these linear quadratic polynomials as a geometrical methods, and geometrically on a graph papers, and plot its by means of 0 and calculate its points also. So conditions we have given here is straight line path in the linear equations and 1 degrees, and here is a quadratic equations always be at 2 degrees. We can recognize, and the degree can be given that if the 2 degree 1 degrees is given, the which types of the equations would be as a polynomial point of view. Thank you very much for coming our channel. So and please don't forget to subscribe this channel so that you cannot miss the video. Thank you. Okay, bye bye.